All right, welcome back. So we're still talking about scientific realism. We've seen Larry Loudon's arguments that scientific theories are not true, or at least we have no good reason to think that they are. Um, so now we're going to consider ways that you can still, right, say that science is true or something close to true, um, even taking into account Loudon's arguments. This article is on the von Frossen constructive empiricism, but I think it might be helpful to talk about first an earlier version of empiricism, which happened around, I don't know, the early 1900s, because von Frosten sort of got that in the background of what he's talking about. So it may help you understand what's going on in the von Frosten. And then we'll move on to constructive empiricism. So logical empiricism is you would sometimes call logical positivism. So again, early 20th century, there's this movement called logical empiricism or logical positivism. It's associated with Carnap. They were inspired by Wittgenstein. They sort of set up the stage for the contemporary realism debate. Um, but their concern was with slightly different problems than what we're talking about now with Loudon and people's induction. Um, but nonetheless, it's looms large in the background of everything we're going to talk about. So they were primarily concerned at this point by distinguishing science from metaphysics. Up until this point, they had been in many ways mingled. You have to remember that, you know, the university we're at and the way it's structured now was not the same even necessarily, 150 years ago. So the logical positivists, they were, I think, primarily philosophers. There may have been scientists involved, right? So, but they're philosophers of science, and they did not like metaphysics that was practiced at the time. Now, granted, this is before Quine, so metaphysics was a bit muddled. Uh, but they were particularly annoyed at philosophers like Hegel and Heidegger, who, if you ever tried to read, very difficult stuff, very abstract, very wordy, and they suspected um, meaningless. They thought it was total nonsense in a lot of cases. So they decided to come up with a rule, a criterion to distinguish when somebody's talking nonsense or not, right? What sorts of statements actually have meaning and what sorts of statements are nonsense. It sounds a little like Hume, right? Hume was engaged in sort of a similar thing when he was trying to figure out, is there a necessary connection between events? What does this mean? He was trying to say, is this even a meaningful concept? Right? Does it connect to anything in the world? How could this concept have entered our brains? Or is it just so much fluff, right? And they're basically doing a similar thing. So they say, look, if a statement is meaningful, it is either true or false. Now that overlooks a lot of meaningful statements, right? Um, you might say that's a meaningful statement, even though it's not true or false. But let's say they're sticking with, they're just talking about descriptive statements, right? Or the sorts of statements you would want to use in a university where you're trying to describe the world, right? So they say, look, it's either got to be true or false. And if it's true or false, and this is the important step, there must, at least in principle, be some way of determining whether it's true or false. Now they say in principle because they say, okay, we may not, for example, there is a boulder, there's a 3 meter by 3 meter boulder on the dark side of the moon. Okay, maybe at a certain point of history, right, it would have been impossible to fly to the moon and find this, whether this boulder exists, but nonetheless, it's the kind of statement that could be true or false. Imagine a way that that could be verified, right? And their example of the sort of statement that can't even in principle be verified is a quote from Heidegger, um, where he says, "The nothing nothings." Obviously, that's in the context of a much sort of broader philosophical point he's trying to make, but on the face of it, yeah, that's sort of what could that possibly mean? How could we ever possibly determine whether that's true? There's an interesting article where that argues that they're not really just beating up on Heidegger, but that Carnap was actually very familiar with Heidegger engaged with Heidegger. But at any rate, that's their sort of poster boy for a meaningless philosophical statement, the nothing nothing. How would I even know if that's true? I can't even come up in principle with a way to determine whether that's true, then it's meaningless. Now, a little too simplistic as stated, right? Because the logical positivists like science, and they did want to some scientific statements, but um, there are a lot of scientific statements that are not verifiable by observation, right? Um, even in sort of in principle, right? Because they're things that are small or things that are actually just invisible, right? Electromagnetic fields. So they have to break it down and get a little bit more complicated about what they mean, what statements are verifiable and which are not. First of all, um, one important class of statements are what they call analytic statements. Right? So some statements you don't need to do observations to determine whether they're true or false. They're just true or false in virtue of the meanings of their words. Mathematical statements, they think, are of this sort. Um, I think people would probably agree, right? And also statements like all bachelors are unmarried. It would be weird to do a scientific investigation to figure out if, in fact, all bachelors are unmarried. If you know what the word bachelor means, if you know what the word unmarried means, you know that that sentence is true. So the logical empiricists think there's this whole class of statements that doesn't, this meaningfulness criterion doesn't really apply in the same way. Analytic statements can be determined to be true without any sort of observation. So here's their more precisely stated verifiability criterion of meaning. Any meaningful non-analytic statement, off the analytic statements, married. Any meaningful non-analytic statement must be verifiable by observation. And sometimes in fact, they sometimes made the stronger claim, which the meaning of a statement just is its method of verification. Um, so this is still fairly bold, and you might think on the face of it false, right? Even just looking at science as it's practiced. In both science and metaphysics, um, there are lots of statements that we take to be true that aren't even verifiable in principle by observation, right? So the nothing nothings, well, that's one they want to carve off as meaningless, right? That even in principle can't be verified. We would want to say it's true that electrons have negative charge. You can't observe that directly. You can't observe charge directly. You can observe, the result of it, right? I can observe two magnets moving towards each other, but I don't observe the charge, right? So what would they say about that? So this is their strategy. They want to translate statements about things we can't observe, statements about things we do observe, and say what you really mean to say when you talk about charge is something else. You're just you should be right. If you were being more careful, you wouldn't have said electrons have negative charge. You would have said the other thing. Well, I can't see subatomic particles, right? I can't see charge, but what I can see with the help of some instruments is a trail in a cloud chamber, right? So this is a picture of a cloud chamber, and you see that little trail. So um, we take those little trails and to indicate the presence of a subatomic particle, and given the size of it, we can determine whether it's an electron or a proton or something else. And then, given the way it moves, the direction it moves in the charged field, we can also say what sort of charge it has, right? So logical positivists are saying that when I talk about electrons having negative charge, what I really mean to say is I'm talking about things I see in cloud chambers. Right? I'm talking about this photograph right here, and strictly speaking, I should translate all my talk about electrons into observations in cloud chambers. Um, so that's how we can separate talk about electrons from Heidegger's talk about the nothing nothing, right? I can do that sort of translation with electrons, right? And I could every sentence about electrons I can translate into things about things I can actually observe. But they argue with Heidegger's The Nothing Nothings, there's no such translation available. So that's how I really know that Heidegger is speaking nonsense. Scientists are not speaking nonsense. They're just sort of using little verbal shortcuts to talk about observable phenomena. So here's the full logical empiricist account um, of how we do science and how we know that science is meaningful and true. First, we divide our terminology into three types. We've got the logical vocabulary, which is basically the analytic statements, right? Um, and then the observational vocabulary, talk about, photographs of cloud chambers, um, right, litmus paper, color litmus paper, stuff you can see. And then three, the theoretical vocabulary. So that'll be talk about electrons. Um, so the truth value of statements in the observational vocabulary, right, the number two, those can be determined just by observation. So things like moves left, right, reads 3 on the dial of my instrument, turns pink like the litmus paper. The truth statements of the things in number 3, the theoretical vocabulary, um, can't be determined directly by observation, right? So this theoretical vocabulary might talk about things like acidity, gravitational fields, electrons, charge, things like that. So the things in class 3, in order to make them meaningful, you need correspondence rules that relate them to sentences in, right? So you need to be able to translate acidic into turns litmus paper red or something observable, right? Is an electron to produce a certain image in a cloud chamber. Okay, so that's their approach. There are some problems with it, and it's not currently the dominant science, right? So first of all, a mistake to say that the word can be translated to turns litmus paper red without loss of meaning there. Right? That's not an adequate translation. Acidity means all sorts of things. Acidic means it will dissolve grease. Acidic means it will burn skin, and so on, right? So at the very least, they would need to add a few more disjunctions, right? More or statements. Um, but it might end up having to be infinite, right? So the term acidic means turns litmus paper red, or burns skin, or cuts grease, or all the other things do, right? All the ways it might relate to observation. So you might need an infinite disjunction, and if you don't like infinite disjunctions, then that might be a problem. And there are other problems with logical empiricism. There's a sort of a strictly logical one. Um, so these correspondence rules between theoretical terms and observational terms are conditionals. So it's something like a sample is acidic just in case if it is applied to litmus paper, then the litmus paper turns pink, right, or red. But we've seen similar things before. This is without getting too deep into the trying to explain the logic. Just take it as gospel that conditionals are true when the antecedent is false. That will mean that anytime something is not applied to litmus paper, it will be acidic. Right? So if I never put my dog on litmus paper, it's going to turn out that that's acidic because it makes that conditional true, right? If applied to litmus paper, it turns red. It was never applied to litmus paper, so the conditional is true. The milk in my fridge, this computer, right? So you can kind of monkey around with the logical form of the correspondence rules to fix the problem. You would have to actually read something like this. If the sample is applied to litmus paper, then it is acidic if and only if the paper turns red. So in that form, it doesn't have the problem. But now we have the problem that it doesn't. It looks much less like a definition of acidity, right? Other problems for logical empiricism, or as we've seen, laws of nature are supposed to be generalizations of some sort, like a universal generalization. The problem with universal generalizations is you can never verify them by observation, right? So, right, the claim that all ravens are black, you will never prove that true. You would have to observe not only every raven on the planet, but every raven that will ever be born in the future. Right? So, you can't, right? So it can't be verified. So you want to account for laws of nature and say that those can be meaningful statements, you would have to weaken the verification condition uh, to something like corroboration. We don't really get that's a term that's thrown around in philosophy of science to be like, well, if we can't say it's true because we can't say for sure that it's proven, we'll just say it's corroborated, right? So, right, maybe that will work. But I'm just pointing out some of the problems, and then yeah, people will go on and write more and more papers trying to solve those problems. So maybe corroboration instead of truth is the direction. Yeah. Okay, and finally, the logical empiricist sort of account of what theories are. It is probably not the dominant contemporary one. So they treat theories as sets of sentences, right? And what people call this a syntactic view of theories. A much more popular view these days is that theories are something else. We call them models, right? Um, and it just sort of captures a broader. Um, if you look at actual science and how it progresses, um, a lot of scientific theories aren't necessarily best described as sets of sentences, and instead maybe models, right? For example, DNA, right? The double helix model of DNA. Um, you could right? You could describe that model in terms of sentences, but really it's a, in fact, when, right, was it Watson and Crick, for instance? Yeah, Crick, when they developed the model, it was a literal model. They were building it, right, half like wire. Um, it's sort of a picture, right, of what it looks like. So this talk of like approaching science as a model is just tries to capture a broader range of the ways scientists approach their theories, right? Um, but then you got the question of what is a model, right? They're not all made out of string and wire. Some of them are much more abstract. It could be a mathematical object like a function, and that's your model in your scientific theory. Um, Often, right, if you read a lot of scientific papers, there are lots of diagrams, and those are meant to be, in some sense, theory, right? So maybe it's what they're trying to capture with their diagram. Maybe it'll be something else, right? Again, this is another direction to take, and maybe in a philosophy of science class. But the point being that, like the logical empiricists are tied into a syntactic view of theories, and that may not be the best way to say what a theory is. A theory might be more something like a model, which is a much broader uh, sort of thing. And the last point on logical empiricism before we get into the constructive empiricism will be relatively short. Couple main takeaways that I want you to get is that however your model, right, your scientific model, your theory is idealized, it's never going to correspond exactly to what goes on in the world, right? So if you just look at Newtonian physics, they talk about point masses, right? So it describes masses that have no size at all, right? Um, and those using those equations are useful, right? And you can often apply it to real world things, but it's not strictly speaking describing anything that exists in the real world. As far as we know, there's no non-spatial, right, point or something with a size of zero that has a certain mass, right? Um, if you get into chemistry, Charles's law describes ideal gases, but there are no ideal gases in the world. So, mean that the theories are false, right? That the entities they describe don't exist. Um, we'll talk about similar issues a bit uh, more this week, right? And the main point is going to be: do we have any reason to believe that our current scientific theories are true, right? So this is the point we're getting at, right? Okay, so now with that background, I think it will help us understand reading of empiricism. So according to von Frosten, to be a scientific realist, you're saying two things. Right? You're saying something about what a scientific theory is, and then also what it does. So here's von Frosten's definition of realism. Science aims to give us, in its theories, a literally true story of what the world is like, and accepting a scientific theory involves believing that it is true, right? So to be a realist, you have to do two things. Um, you have to be committed to what scientific theories are trying to do, right? And you have to be committed to what is involved in accepting a scientific theory. And the realist says, again, they're trying to tell you a literal truth about the world, and when you accept it, you're saying it's true. And I think this is I would be the default that most of you walked into this class thinking about science. Yeah, science is telling us literally true stories about the world, and yeah, they're true. Okay, so this first part, what the aim of science, right? So, according to realism, science is trying to give us a literally true story of the world. Now, when we talk about the aim of science, this may differ from the individual motives of individual scientists, right? Scientists may be whatever, they're just trying to make money. I'm just trying to make ends meet, man. I don't really care if it's true, right? But the point is that when he talks about the aim of science, he's talking about the overall enterprise of science. What is science up to? And he's using the term literally on purpose to rule out views like logical empiricism, right? So the logical empiricists do not think that scientific theories are literally true because they first need to be translated into observational terms before they can be true, right? So von Frossen is saying if you're a realist, you can't be a logical empiricist. You are claiming that no, science as stated is literally true after it's translated. Okay, and the second part, if you're a realist, you accept a scientific theory, and that means you believe it is true. Right? So if I accept that our current physics is true, then if I'm a realist, that means I believe that all the particles they're talking about exist. Electrons exist, neutrons exist, whatever's in the theory, right? This is risky because, as we've seen, theories change over time, right? So if I had been committed to if I had accepted phlogiston theory, right, I would have been wrong, right? Turns out phlogiston does not exist. So if you're a realist right now, you're saying uh, none of these scientific terms are going to go away and be replaced, right? We're going to be talking about quarks forever. You know, if you believe string theory, if I accept string theory, then I would say, yeah, strings are the basic particles, the basic constituents of matter, and that's never going to be changed in the future. So it's a strong. His point is a strong stance to take. Scientific realism. Right? Now, um, you might want to just accept the first part, but not the second part. I'm a different kind of realist. I think science is aiming um, at truth, right? Uh, but I'm going to hold off on our current theories, right? I'm going to accept them if you want. So von Frosten is a constructive empiricist, right? So he is reinterpreting what science is up to, um, and he doesn't think the science is aiming at literal truths about the world. Instead, science is only aiming at empirically adequate theories, right? Science is true. I'm only accepting that it is empirically adequate. Uh, so this differs from realism, right, on both points 1 and point 2. So constructive empiricism denies that the aim of science is to produce theories that are literally true. Now, again, individual scientists might think that's what they're up to. Right? They might be realists, but von Frosten thinks they would be wrong about the aim of science more generally. Right? And he's not making the same move as the empiricists, right? So the empiricists did think scientific theories were true, you just had to, but not literally true, you had to translate them, right? Von Frossen is saying that, right, he's threading sort of a tricky needle, right? So he says they are to be taken literally, but the truth is not the aim of science. Right? The real aim of science is to produce true predictions, right? And understood that way, yeah, literally they are trying to produce true predictions. Right? Literally true, it's not literally true. It's to be taken literally, but it's not trying to be true. It's just trying to be empirically adequate. Okay, so what does it mean to be empirically adequate? So a theory is empirically adequate if and only if what it says about the observable things in the world is true. And a theory is going to say a lot about things that aren't observable, right? Electrons. Um, those things don't have to be true, right? It don't to be empirically adequate. It only the parts that mention observable things have to be true. And this, now notice, right, this is a stronger claim than just like everything that has been observed. Yeah, it's talking about all future observations as well, right? So again, science is, even on von Frost's account, science is trying to do a lot, right? It's trying to make true predictions about the observable world for all time and everywhere, right? Um, but is only being held to its observable consequences. It's not saying that when it says the word electron that that's true. Okay, so what does it mean to accept this? Well, it means to believe in it. It means some other things as well, right? So most theories are not complete yet, right? We're working out our theories. And there's a term that we use to call that, where like there's a dominant sort of like paradigm, right, in science and in the moment, right? We call that a research program, right? Working it out, it's not complete, but everyone's sort of on the same track. Right? So if you accept a theory, you're committed to that research program. You're committing to viewing the world using the resources of that theory. And whenever you attempt to explain a new phenomenon, you're trying to use the resources of that theory. So it's sort of like a belief system, right? Like being a Catholic or a libertarian, which says, I believe in the sort of this interpretation of quantum mechanics, right? This is my research program, and I'm going to endeavor to explain everything in terms of that particular interpretation of quantum mechanics or something like that. Okay, so again, according to constructive empiricism, science is only committed to observable stuff, right? Um, so what counts as observable? Well, some stuff is obviously observable, shoes, tables, things like that. But what about observation through a telescope or a microscope? That observation is not unaided, right? Um, and von Frosten says yes, right? As long as there is some circumstance where you can observe it, it is observable. You need a microscope, an electron microscope, a telescope, that's fine. So this will include the moons of Jupiter observed through a telescope. It's not going to include electrons in a cloud chamber, right? Because you're seeing the track in the cloud, but you're not seeing the electron itself, and so you do not observe the electrons. So electrons are not observable according to von Frost. So statements about electrons are not going to be taken. Now, what counts as observable might change. He points out, right? What if we absolve and we evolve in some way, or there's a mutation, all of a sudden I can see infrared radiation, right? I'm like a snake all of a sudden. Well, he says what I mean by observable is actual present human capabilities. Um, if our observational abilities change in the future, then what observable will change too. And if humans evolve to see infrared radiation, then all of a sudden that will count as observable, right? That's fine. Okay, and final point, right? Often in science, we talk about theoretical virtues, which means things like simplicity or strength, like the amount of predictions it can make. And sometimes um, scientists defer to those things, which are not strictly, observable, in order to choose between theories. Like, so for example, put yourself back in like right, the Renaissance era, what was it, I don't know, 1600s, something like that. Right, we don't have pictures of the Earth, right? We haven't looked at the Earth. We don't know. All we know about the solar system is sort of what we can see through a telescope, right? Well, in that case, you've got your Copernican view of astronomy, which says the sun is at the center of the solar system. You've got the Ptolemaic, which says that the Earth is at the center of the solar system. And we can't make an observation that would decide between these two, right? All we had were the theoretical virtues, and the Copernican system had a lot of theoretical virtues. It was much more simple and elegant, right? I talked about these epicycles that the Ptolemaic system had to evolve, right? Orbits within orbits in order to get the observations right, make the right predictions. Well, some scientists would say, yeah, even before you could get off the Earth and, observe the solar system, um, you could decide between the Copernican and the Ptolemaic theories because the Copernican is more elegant, or it's got these theoretical virtues. Well, constructive empiricists can't use theoretical virtues, right, because they're not observable. Um, so that means they're going to have to, until we can make observations to distinguish between theories, they're going to have to accept both theories. If they both are empirically adequate, then they're both perfectly good, right? So if I were a constructive empiricist back in 1600, I would have had both the Copernican and the Ptolemaic theories are good, right? But von Frosten doesn't think that's going to be a big problem, right? Because first of all, when it counts, he thinks most of what we care about are the observable predictions. And as long as those turn out true, then it's going to be a very useful theory, right, as far as getting us on the moon and curing diseases and stuff like that. And then eventually, as technology improves, hopefully, right, eventually we could observe that, the sun is at the center of the universe, not the Earth. So he doesn't think that's going to be a big problem, but he accepts that, yeah, this is the case for constructive empiricism. We can't use things like simplicity and strength to decide between theories. Right? We can only stick with observable evidence, right? Observable predictions. So that was the point of the the constructive empiricism. I hope that makes some sense of the lecture, and I'll see you next time.